Let's move on. Next example. Your great-great-great-grandfather deposited $10 at 5% interest 300 years ago. By the way, when a problem does not clearly state which time period the interest rate is for, you should always assume it's for 1 year. So 5% interest should be interpreted as 5% annual interest rate. 3 questions. How much is the investment worth today? The second question is, how much would it be worth today with simple interest? And the third question is, how much more is it worth today with compound interest? So you already know from the earlier slides that with compound interest, money grows faster than with simple interest. So how much of a difference does it make over 300 years? Well, we can answer the first question using the financial calculator, right? Or we can try it by hand first if you want. You're actually free to pick any calculation method you like. You can do everything by hand using the formula from the earlier slides, or you can use the table in Appendix 1 to find what these future value factors equal to, or you can use the financial calculator. You can actually also use Excel. There are ways to do it very quickly in Excel. The answer to question 1 is approximately $22.7 million. So that's how much you would have in your account now from $10 deposited at 5% 300 years ago. In the financial calculator, again, 10 would be your present value, what you started with. And you would change it to a negative value so that when you find the answer, the future value, it will be displayed correctly with no negative sign next to it. Then 5 is your interest rate, 5 IY. 300 is the number of years, right? Let me try it in the financial calculator again. So we have the present value of $10. Make it negative, press PV. 5 is the interest rate per year, 5 IY, interest per year. And 300 is the number of years over which the interest was earned. Compute future value. Here is the number that matches what's on the slide. The second question is, instead calculate the future value after 300 years with simple interest. Here the math works a bit differently. How much interest is earned every year? It's always the same amount. It's always 5% of $10, which is 50 cents. We earn 50 cents 300 times, which increases the money in the account by a total of $150. And with the original $10 that was deposited, we are now at $160. Big difference, right? The answer to the third question, the difference between the future value with compound interest and the future value with simple interest, is enormous. 22.7 million versus 160. Big difference. This is what we call the power of compounding. Next question. 8 years from now, you plan to buy a new car. When you graduate from Cal Poly in 3 years, you will deposit $10,000 towards your car purchase into your savings account. If the annual interest rate offered by the bank is 4%, how much money will you have available for the purchase? Well, again, it's a future value problem, right? We need to compute the future value. There is a trick in this problem, and the trick is, what do you use for the number of years? Do you use 8? Do you use 3? Do you use 5? The correct answer is 5. Because what you need to understand is T in the future value formula, or N in the financial calculator, means over how many years the interest is earned. So in this problem, you make the deposit 3 years from today. So the first 3 years don't count. Nothing is happening. There is no money growing. Everything is delayed by 3 years. So between end of year 3 and end of year 8, your money sits in your bank account and earns interest. How many years? 5 years in total. So the answer will be $12,166.50. And again, you can do this in the financial calculator. Make sure you use 5 for your number of years, N. Let me bring up the financial calculator to show you. Let's clear everything. Second, clear time value of money, or what I recommend, full reset. Second, plus minus, enter. Let's increase the decimal places just to practice. Second, format, let's make it 4, overwrite 2, enter, done. We are depositing $10,000, so I put 10,000, I change the sign to negative, and then I hit PV for present value. The money will be growing at 4% per year. I press 4 IY, interest per year. It will be earning interest over 5 years between the end of year 3 and the end of year 8. I press 5N, and I need to compute the future value. Compute FV. $12,166 and approximately 53 cents. It's actually 5290, like on the slide. Next question. A friend of yours lost in a bet, and so he now owes you $500. He is also offering you to instead pay you back $530 in 1 year. Which one should you accept? You also know that the money that you have stays in your savings account and earns a 7% annual interest per year, in case this information matters. And it does. So how would we solve something like this? Well, let's say you choose option number 1. You choose $500 now. What happens next? You're probably not going to keep it at home in cash. You're going to put it in a bank account. Maybe invest somewhere else. If you put in your bank account at 7% interest, then after 1 year, it will grow to 535, right? And again, you can verify the math in the financial calculator, right? Let's clear everything. Second, FV, or my preferred way of clearing is a full reset, just to be sure. Second, plus minus, enter. We can increase the decimal places. Let's do that. Second, format, let's make it 4 and press enter. So you take $500 today. We need to set it as a negative value, plus minus key, then press PV, which stands for present value. It will earn a 7% interest rate, 7 IY. It will earn it for 1 year, 1N. And now we can compute the future value. Compute CPT key, future value, FV key. $535 exactly. There are no cents. What's our conclusion? You should take 500 today. Why? Because in 1 year, it will be 535. If instead you take 530 from your friend in 1 year, that's $5 less. And let's do one more example. Turns out this formula to find the future value can be applied to a lot of other things. It's not just all about money and how it grows due to earned interest. Let's look at these three examples side by side. In the first example, your company has 500 employees. Each year, the company hires 1% more. How many employees total in 20 years? Well, if you use the future value formula, then 500 employees is the equivalent of the principal amount. Hiring 1% more is the equivalent of earning a 1% interest on your money. And 20 years is like in the future value formula. It's also years. So if you use the formula, you can either use 1% for the growth rate, or if you're putting the growth rate in decimals, you would need to put 0.01. The answer will be approximately 610. And these are the keys you would press in the financial calculator. Again, in no particular order, you would enter PV, N, and IY. And then at the end, you press compute FV. Second example, let's say you love cats. You currently live in a teeny tiny apartment. You have 2 cats. Let's assume both cats are female and that each year they will be producing a kitten. And each kitten will also be producing a kitten every year starting the first year. So what does it mean? If you have 2 cats now, how many cats will you have total in a year? 4. How many will you have 2 years from today? 8. How many cats will you have 4 years from today? 16. Then 32, then 64, and so on. So the number of cats doubles every year. And the question is, how many cats will you have in your teeny tiny apartment in 20 years? So the number of cats doubling every year is like 100% increase every year. You can use the future value formula and use 100%, or in decimals, that would be 1. That's the equivalent of the interest rate when we work with money. The answer will be not hundreds of cats, not thousands of cats, but a little over 2 million cats. 2,097,152 cats. That's in your teeny tiny apartment. And these are the financial calculator keys. And the last example. In this article here, I read that there was a study done on the price for TVs between 2000 and 2018. And between 2000 and 2018, televisions experienced an average inflation rate of negative 16.45% per year. Negative. So they have been dropping in price. Let's use this information and calculate how much today's $1,000 TV would cost in 20 years. What's the trick in this problem? 16.45% is not an increase per year, but a decrease. It's equivalent to a negative interest rate. Can we do that in our formula or the financial calculator? Yes. Just put the minus sign. In the financial calculator, you would set your IY, interest per year, to a negative value, just like you do with present values. And the answer you will get is $27.47. So a TV that costs now $1,000 will cost less than $27.50 in 20 years. If prices keep falling at the same rate they have been falling since the year 2000.